All right, number 4, list 4 ways in which the Calvin cycle is controlled by light. There's a lot of stuff I would accept here. The first one, which is maybe not the best answer, but it actually does, I would accept it, is basically the ATP and NADPH that are being generated by the light cycles are actually used by the Calvin cycle to carry out its chemistry. Now, the reason why I wouldn't say I'd say this isn't necessarily the most complete answer is that there are other processes in the cell that can also generate ATP and NADPH. So, for instance, the pentose phosphate pathway can generate NADPH. So, the Calvin cycle could theoretically get some NADPH from the pentose phosphate pathway even with the lights off. Anyways, though, obviously the light reactions do produce substrates for the Calvin cycle. So that is a mechanism of control there. Now, there are a few others, some of which I went into it during the lecture and some of which I didn't, that are nonetheless contained in your textbook. All right, one of these is that what I'm drawing here is a thylakoid. Now, the outside here is then the stroma. Now, what happens during the day is that the photosynthetic electron transport chain pumps protons into the thylakoid. So the pH outside in the stroma is increasing during the day. And this higher pH here actually activates rubisco. So rubisco is active at higher pHs, but not active at neutral pHs. So this is another way the Calvin cycle is controlled by light. Now, a mechanism I didn't go into is that when the protons are being pumped into the thylakoid, to kind of charge balance, some magnesium ions actually get pumped out into the stroma. And magnesium is actually an activator of rubisco as well. So the rubisco is being activated by the increase of pH as well as the presence of this magnesium ion that's being pumped out into the stroma. Now, further type of stuff. Now, there's a this is kind of a little side thing, but rubisco is inhibited by a compound called Ca1P that's produced only in the dark. So when it's dark, there's lots of the Ca1P, which is an inhibitor of rubisco activity. In the light, basically, there ends up being less of this in the light, and so rubisco activity goes up. So this is basically an inhibitor that the plants make only in the dark that helps to also turn off rubisco at night and activate it during the day. Now the last portion here is that during the day, the photosynthetic electron transport chain is working, and some of these electrons can be donated on to reduce disulfides using a protein called thioredoxin. And thioredoxin now can take certain enzymes in the Calvin cycle, enzymes such as FBPase and SBPase. So are two phosphatase enzymes actually. And when they have disulfides on them, they are inactive. So if they have disulfides, they're inactive. Now, disulfides can be converted into thiols by reducing them using thioredoxin. In order to do reductions, we need electrons from the light reaction. So the other way that the Calvin cycle is controlled by light is by taking electrons from the electron transport chain, transferring them to thioredoxin that can then reduce disulfide bonds on FBPase and SBPase, are two phosphatase enzymes, now turning them into no longer inactive enzymes, but now active active enzymes in the Calvin cycle? And that is it for this question.